Welcome back to another exciting chemistry lesson. In the previous lesson, we learned how to calculate for KSP, basically solubility product, using the ICE table. Now, in this lesson, we are going to look at how to interpret KSP and basically look at solubilities of a chemical reaction. The first thing we have is something called common ions effects, and that is when we're working with solution, we talk about solubility, mixing substances and make a solution. Sometimes we have common ions, that is ions with the same charges or behave very similarly. They affect the dissociation, that is another word for solubilities of a substance, specifically of an ionic compounds. In this case, we're looking at. So common ions affects decrease dissociation of an ionic compound in a solution due to the presence of one of the ions that's being produced. So let's look at this example. We have calcium fluoride, and this dissolves into calcium ions and fluoride ions. You can see that right there. So as you can see, we see the ions that's being produced, but here's the trick. What if we introduce other substances in the solution that has ions of calcium fluoride as well? So let's look at an example problem. Predict in which way let's look at an example problem. Predict which way the reaction will shift toward the reactant side or the product side to reach equilibrium again after each changes below. So an addition of calcium nitrate, as you can see here, this calcium nitrate is soluble. So we really have to pay attention to the problem. They can trick you by putting something insoluble and therefore has zero effects on it. So again, it has to be soluble. And what's the key thing you have right here? Calcium right there. So if that's the case, if we put this into the solution, the calcium would increase. And therefore, it would shift toward the reactant. This is a reversible reaction. You would have more calcium fluoride being produced. So it shifts toward the reactant side, make more reactant, which in the end, make this less soluble. You see how that works? Because you are increasing the concentration on the product side, so therefore it is shifting away what's being added in, just like we learned in the shallow layer principle. The next thing we are going to look at is the values of KSP. Well, we learned how to solve them, but what does the value tell you? The key part is that in most problems, it gives you different values of different substances, and you had to compare them in terms of solubility. What does that really mean? Well, solubility product measures the dissociation, that is the ability to dissolve in a solution. The greater the values, the more soluble it is. So when you look at a table, the greater the values of KSP, the greater dissociation. That means it produces more ions, okay? So be very careful with that, because they are not going to give you some very basic statement. They are going to give you data, and you have to interpret by looking at KSP. The last thing we are going to look at in terms of solubility is how it is being affected by pH in the solution. And we already learned that already. From 0 to 14, 7 is neutral right here, right? This is your water right here, pure water. And from here to here, it is getting basics. And from here to here is getting more acidic. So what does that really mean, more basic and acidic? Use basic term, using this term right here. Hydronium ion, which is sometimes represented by H plus OH minus, produce water, okay? So getting more basic, that means it is increasing in terms of OH minus. When it's getting more acidic, it is producing more H plus concentration. So keep that in mind. So let's look at this. How is this going to affect our solubility? Well, most ionic compounds has H plus or OH minus, especially when we're talking about a basic ionic compound like this, calcium hydroxide. Okay, there you go. You have the OH minus right there. Or in this case, if we look at HCl, this is an acid right here. And this is a base right there. We already learned that already in the past. So by looking at the chemical formula, we can determine if the solubility of that compound will increase at a high pH or at the low pH. So let's look at this. At low pH, you are talking about more acidic, so therefore has high concentration of H plus. Well, let's put it that way right there. So therefore, at lower pH, it would decrease the solubility of acidic compound, because again, we are increasing the values of H plus. If I'm writing this as an acid, right, producing H plus and A minus right there. This, you see right there, if we're increasing that, it's going to shift the reaction that way. It makes sense. And if we are increasing the pH, what does that really tell you? Well, if we're increasing the pH, we are introducing OH minus, and this one, what do? They react to make water, right? So therefore, it has the opposite effects. Increasing the pH in acidic compound, it would increase the solubility. Now let's look at pOH, okay? Well, higher pH, greater than 7, is basic. We're basically introducing that right there. And now we look at this, we're talking about basic compounds. So remember, you have to really read the problem carefully. This is for the base. This is one for the acid right here. So you have to identify the compound before you can apply this rule. So at a high pH, we would decrease. Okay, so let's look at this. So we have, let's look at base OH right there, produce, okay, OH minus plus B plus right there, as you can see right there, okay? And what do you see? Well, look at this. We have this right here. As we are increasing the pH, we're increasing that, right? So therefore, it's shipped that way. So therefore, it's gonna decrease its solubility. And vice versa, if I'm introducing H plus here, by increasing the pH, this will produce H2O. So therefore, it's gonna ship that way because removing the OH from the reaction. So keep in mind, when you solve this particular problem, usually present in multiple choice, look at the chemical formula, determine if it is a base or an acid first before you apply the Chatelain principle right there.